Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology under the LG University. Now so far we learn about the mean terms and max terms. What are the literals? So from mean term and max term we would able to understand about the two form. One is called SOP form and another one is called POS form. Now we are not much concerned with the POS form, or we are sticking with the SOP form, which is called sum of product form, where all the boolean terms whatever is given to you always in terms of the SOP term and always represents the mean terms. So mean terms, that means the answer is always 1, right? Based on this criteria, we try to learn about the K-map system. Again, a reduction of Boolean function using the Carnot map, right? So far what you did, you have reduced the Boolean function using the Boolean algebra. This is the one way of method to reduce the Boolean function. Another way of method to reduce the Boolean function is using the K map, right? So first, based on the literals, we will map a kind of Karnaugh where we will define or we will make a block of mean terms, right? So you always know the mean terms answer is equal to 1. So first we'll start with the K map with the two literals where you have a two literals, that means total 4 mean terms you are going to get. Like if I'm going to take two literals like A and B, I'm going to have the total 4 terms. It's like AB, A bar into B, A into B bar and A bar into B bar, right? So by from that way, see, I can be able to map my Carnot is like I'm going to take A either 0 or 1. I'm going to take B either 0 and 1. And based on that, if A is equal to 0, that represents A bar. If A is equal to 1, represents A. If B is equal to 0, that represents B bar. If B is equal to 1, that represents B, right? By that way, you have a total 4 blocks. You can see first block where A is 0, B is 0 is represented by M0, small m0. So that is nothing but A bar into B bar. You can check here first row and first column. Same way here. First row and second column is 0 and 1. So that is represented by A bar into B. You can check the second row and first column 1 and 0. So it is A into B bar, and second row and second column is AB, that is 1 1. So it's a into B. So this is what how you can represent the K map. You can also take the three literals and based on that you can do this. Now let's say we want to implement this particular function as the canonical form or SOP form is given to you. F of ABC is equal to 0 1 and 2. So this mean terms values are 1. So I'm going to put this corresponding is like 0. A and B both are 0 0. Answer is 1. 0 1, answer is 1. 1 0, answer is 1. And but both are 1 1, that is represented by M3, answer is 0, right? That I want to make the in K map. So you can place the 1 as the corresponding block, like M0 is represented by 1 because it's given 1, M1 and M2. So from that, your job is to make the group of ones. Maximum ones you have to incorporate in a group such a way that you can reduce the number of literals. So if the number of literals is going to be reduced, the number of mean terms is going to be reduced, and at the end, the number of logic gates is going to be reduced, right? So that's what our main aim is, to reduce the number of gates. So we do not believe in making the big complex logic circuits or digital logic circuits. We want to make a simplify. We want to make a simple and less sized digital circuit. So once you make the group of ones, like you can see there are one group which is narrated or here drawn with the blue color, where both the 1 1 position of row 1, that means here there is no importance of B. For both the ones in a group of this blue color circle, you can see B is 1 and 0 both incorporated. So there is no meaning of B, but the A bar that will cover the complete row, like having the 1 1. So my one of the answer is A bar. And you can check the second group, which is circled with the red color, where it incorporates first complete column or whole complete column, that is represented by B bar. So here my answer is A bar plus B bar, right? So that's what my answer is here. So my answer is A bar plus B bar, where your job is to make the maximum number of ones or incorporate maximum number of ones in a group, right? So by that way, again, we'll go for 3 literals K map, where this kind of K map we are going to use for designing some of the modules like full subtractor, half subtractor, full adder, half adder, multiplexers. So from that, likewise, like 2 literals, we can also go and discussion about the 3 literals. Now you can check 3 literals, that means there are total 8 mean terms, and 8 mean terms are placed like A, B or C. Once you take A, B, see in all the rows, like AB sequence is 0 0 0 1 1 0 and 1 1, and C sequence is 0 and 1. Same way you can go for the second, and both either way you can possible of this by taking this map, like either A, or you can take the pair of B and C. So A is either 0 or 1, B and C is like a 0 0 0 1 1 0 and 1 1. Now you can see the third column is very important, having the value of 1 1. Why? Because ultimately B and C will follow the sequence of gray code. That's why, right? So that's very important to understand. So my sequence is 0 0 0 1 1 1 and 1 0 for 3 literals, right? So you can check this. From that, if you take the 3 input literals, see your value, you can make it like this way. My one of the SOP form or function form X is summation of M 3 5 6 7. That means the mean terms of 3 5 6 and 7 are having the value of 1. So in this particular truth table, you can check the sequence of 3, which is 0 1 1. See, having the output X is 1. Same way 5 6 and 7 are having the output sequence of 1, right? Now this corresponding 1 I want to put in a K map. So this is one way of reduce the function. Now what are the limitation of Boolean algebra that we have discussed earlier, where if there are more number of literals, more number of variables, the system becomes more complex, right? And the reduction process is more tough, more tricky. But if you use this K map, see, they can help you up to 2 3 4 5 literals. Beyond that, one more method is going to help you, right? So you can see from the K map, where you we have taken the map is like A and with a pair of B and C. So A is having 0 and 1 value, B and C is having 0 0 0 1 1 1 and 1 0 value. So you can make the corresponding block, like first is M0 M1, the last block is like M2, and the from that the before that last one is the M3. Same way 4 5 6 and 7, and you are putting the M3 M5 M6 and M7 as the value of 1. So now my job is to incorporate maximum number of ones in a group, right? So I am getting the total 3 groups. So your first job is start with the, if you have a 8 block, start with the 8 ones possible. No, then you start with the 4 ones possible. Yes or no? No. Then you can start with the 2 ones possible. Yes. Then you can start with the 1 1 possible, right? So this is what the criteria, this is what the selection rule. So here 2 ones is possible in a 3 groups, so you can find the groups here, and the same one you can take multiple times, because anyway you have to reduce the number of literals, you have to reduce the number of gates. So by that way, the final answer X is equal to AC plus AB plus BC, and that you can implement using the logic gates. So here you can see, so since there is no NOT gate, so this you can easily implement with the help of AND and OR gate, right? Further, if you take the 4 literals, this is a very interesting part, where if you have a 4 literal, so you can see the layout of this 4 literal K map is having the pair of A, B and C, D. So A, B and C, D both are having the sequence of 0 0 0 1 1 1 1 0. Same way C, D having the sequence of 0 0 0 1 1 1 and 1 0. You can make the sequence of rows and column wise. So first M0 position having the 4 zeros, like 0 0 0 0 A, B, C, D. Same way the second block is M1, then the last is M2, and before that is M3. 4 5 6 and 7, and you can check the last row, that is represented by 8 9 10 in 11, and the second last row is represented by M12 13 14 and 15. So you remember this is the sequence, and if you forget the sequence, so your all the answers would be wrong, right? So follow this particular sequences, like pair of A, B and C, D, which is 0 0 0 1 1 1 and 1 0, right? Now based on that, I can take any example, and let's say my example of f of A, B, C, D, that is equal to summation of M is 0 1 2 5 7 8 9 10 13 and 15, and you can write ones in a corresponding blocks, like you can check here, right? Now from that I can be, my next job is to make the maximum number of one, or incorporate maximum number of ones in a group, right? So I'll start with the 16 blocks. So 16 ones possible? No. Even 16 ones is possible. You see, your answer is 1 always, right? Because answer of mean term is always equal to 1, right? Same way, next level is check. 2 raised to 4, 16 ones possible? No. 2 raised to 3, 8 ones possible? Let me check. Yeah, see, 8 ones is not possible in this group, because this group has certain rules where two adjacent ones, the group can be possible. But let's say you have a 1, then you have a empty block, and then you have another one. See, that particular group is not possible, right? So if you start with the 8 ones, all with the adjacent blocks, that group is possible. Here in this case, not possible, right? So 8 ones is not possible because somewhere there is an empty block, right? So from that, you can come to 2 raised to 2 is a 4 ones possible. Yes, there are 4 ones possible, right? So let's say if you are getting multiple groups of 4 ones, you always go for it, because ultimately your aim is to reduce the number of literals, right? Or reduce the number of logic gates. So you can see, yes, 4 ones of 3 group possible. You can check this C bar into D, that is the complete column is having the 1, because I'm putting the 1 in this corresponding mean term is like 0. You put the 1 in a block number 0, you put the 1 mean term as a block number 1. Same way 2 5 7, so it's a 2 5 7, then 8 9 the last row, then 10, then 13 and 15 is the second last row or third row, right? By that way, if you put the ones, you will find the you can incorporate maximum 4 number of ones in a group. So there are 3 groups if possible having the 4 ones, right? So first of the row we can see as a C bar into D. Second group, that is nothing but, see, you can check this one, second one, see, having which is the common literals is B, and the B is from the row, and from the column is D. So my answer is B into D, and the 4 ones are available at the corner of the blocks, they are also possible. So from that, see, from the rows is B bar is common, and from the columns it's D bar is possible. So my answer is B bar into D bar. So once you write this, answer is like BD, first one. So BD represents the group of 2, then C bar into D, that represents the complete column of C bar into D, and B bar and D bar, that nothing but the 4 corners of the block. So by that way you can reduce the number of functions, and you can also implement the logic or digital circuits using this day. Now this is one more example is based on the 4 literals, but here we are taking a kind of term which is f of abcd. You can replace this term using the Boolean algebra, and finally you'll have a specific term. So you can check this particular Boolean function where it is having the mean term of f of abcd, and all the mean terms is like 0 1 3 5 7 8 9 11 13 and 15, and you put the ones in corresponding blocks or corresponding mean terms. So once you are going to put, your first job is to draw the K map having 16 blocks of A, B, and C, D pair, like 0, 0, 0, 1, 1, 1, and 1, 0, right? You can put now corresponding 1 to mean terms or respective blocks, and you find 16 ones possible? No. You can go for 8 ones possible? No. Yeah, but 4 ones possible? Yes. You can check the 4 ones of adjacent blocks 1, 1, that is possible, but one of the empty blocks in between 1 1, this is not possible. So from this, see, your answer from second column and third column, that represents the literal D. Why? Because D is common between these two, where C is going to change the value from C bar to C, right? And then the second group you can check, where from first row and the last row having the common value is B bar, and the first column and second column incorporating this group having the common value is C bar. So my answer is B bar into C bar plus D, right? Now this you can also implement using the logic gates. Now you can check this one of the important example where you have a design of 4 input ABCD digital circuit that will give you the output of X, have logic 1 only if the binary number formed at the input is between 2 to 9. So this is very interesting. If the binary number is from 2 to 9, all corresponding output are 1, right? So from that you can be able to write your SOP form, or mean term form is like 2, 3, 4, 5, 6, 7, 8, 9. That means all are having the value of 1. So you use your K map, put the corresponding ones in a specific blocks like A, B, C, D with the sequence, and from that you can be able to get 16 ones in a group possible. Yes or no? No, then go for 8 ones in a group is possible. Yes. If yes, then go for it. If no, then 4 ones is possible. Yes, here 4 ones are possible here of two groups having the A bar into C plus A bar into B, where in A bar into C, that is the first two rows and last two columns, right? Same way you have a A bar into B, it's completely the second row, so there is no importance of the columns here. So that's why this term is A bar into B. And the last group where the two ones is incorporated in a group, and that is represented by 1 0, and that is the last row is 1 0. That means A into B bar, the last row is A into B bar, and this two columns first and second have the common value is C bar, so that value is A into B bar into C bar. So the complete answer of x is equal to A bar into C plus A bar into B plus A into B bar into C bar. Then complete logic diagram you can put it like that way. So see the student, this is the K map is the simplest one, very interesting one, and from that you can be able to reduce the Boolean function with very less efforts. So this is the what about the K map, right? Thank you very much.